what I would like to show you is oh yeah, the TV is covered in mosquitoes. It's disgusting right now. Like it's fly spray is coming out a little bit later. You put the air fans on max, it sucks them against air fans, and they die. So what we've got right here is essentially a monorepo. It's a monorepo of monorepos. The way I build my software is the idea is I should be able to head into a directory, and you notice when I go into this directory of depot is my monorepo, it's actually going to set up the developer environment, which means even though this is personal, if you were to clone down this repo, it's instantly reproducible. And it allows you to just, all the tools that you need or I need are pre-installed. So if I head across over here, I'll show you what that looks like. And there's a couple of really cool tools, like there's like a depot, which is the main. So if you're familiar with like Google building, you should be familiar with this. Ops/nixos. So depot build nix ops/nixos. So each slash represents a path. // is the root of the monorepo. So right now I'm telling it to build my operating system. But not just my operating system. I have a listing of machines. Right now, this listing of machines is just a singular machine. But as I add more machines, laptops, what else have you, there's a lot of configs I'm migrating across. I can have a singular command running under CI that's going to build my operating system. Now, that means that the building of operating systems can happen at the CI layer, and then the deployment can happen later. Either I can SSH onto the host and run a command. So I'll show you what that command would look like. So there's a couple of different ways you could deploy. This is a good example. So I can just execute this command, rebuild system. So that's what I've got. I've got basically a whole bunch of cron jobs that run every hour, and they just invoke this shell script. It pulls down the latest Git repo and invokes this shell script, and it just redeploys. And that's how I do continuous delivery on my servers. I don't need anything faster than an hour. Plus, an hour is pretty good because you can look at your watch, and with a watch, you'll know that it's 5 minutes past. I've stuffed something up, so I'm going to go into the machine and just touch a file to stop the deployment. So one of the deployment scripts has that. So that's kind of sweet. Another thing that's kind of cool is over in these GitHub Actions workflows. Alrighty, so I try to keep GitHub Actions as minimal as possible. So many people go over the top, and what happens is they start getting vendor lock-in, and they can't move to a different tool because they've done so much with GitHub Actions that it just turns into shit. So here, following the idea of everything is the monorepo, GitHub Actions is just an event executor, responds to events, and it dispatches some compute to build the machine. Here, I have depot build, and that's the same commands I've been showing. So this is something that's really cool, like insanely cool, is over here, this is my configuration for Nix. I use Nix as my build system and my DevOps type things. But what happens is I actually export out the config. So no matter what computer I'm on, I ensure that I get the same Nix config, because when you install Nix, you can configure the amount of CPU cores, there's other little tunables. Here, I've actually got my configuration under version control. I override it with an environment variable, and anytime I go into the directory, it will source this configuration and put it as an environment variable. This also is true and applies to CI. That means the entire idea, it works on my machine but doesn't work in CI. Don't have those problems. Not at all. Like, if it works locally, it works in CI. Like, if I wanted to reproduce CI, I just work locally and then push. Because CI is just an exact replica and representation of my local workflow. Really cool. And something I'd like to show here is, this is really similar is, yeah, absolutely no integration hell. It works really well. So line 40 here is another inbuilt command. So because it's a monorepo, everything is vended. Like, I don't pull from external sources. I vendor all my source code dependencies. So I've got a third-party directory here, and I vendor all of Nix packages. Nix packages the entire operating system Nix package universe. Likewise, I've got Agenix. I was working on Agenix before you jumped in, and I'll get into Agenix. It's the secret manager. Really cool. That's the reason I had VS Code out, because I was working with some secrets. But now that secrets are in there, it's encrypted with SSH keys. I'll explain how that works in a tick. So GitHub Actions works every night, and this is my own version of Dependabot. Really simple. I use GitHub Actions to run the thing, and the thing that it runs is not some externalized thing. It's part of the tooling in my monorepo, in my ecosystem. And it's the same thing that I would run or the server will run. You just run source update, and it updates the pins. So I've got a nightly job that updates the pins. It runs the build, and if the build's green, it auto merges. There's a GitHub action here for auto merge. So that allows me to have reproducible builds. I can always roll back like days. I just roll back to the previous day's commit or where the pin was at. And I can roll back my entire operating system down to particular commits or packages to particular commits, because everything is pinned. Really cool. So I have Depot SRC. Depot SRC is an alias for a package manager called the tooling I'm using called is NIV or NIV. So I can go Depot SRC update, which is the same thing GitHub Actions runs. And it's doing right now, it's enumerating all the different dependencies of my third party. And if I have a look, because I ran it last night, there's no pins to run forward. Lovely. So Agenix. Let's get into Agenix. So secrets are normally something that's really hard to manage. But secret management is infrastructure concern, and when people don't fix it in infrastructure, you get problems. There's many different ways to handle it with secrets, but this is a pretty good one. So if I head over to ops/secrets, I have a secrets.nix, and this secrets lists users, and this is a per user SSH key that's allowed to decrypt or re-encrypt the secret. Likewise, each machine that I have has its host key in here. Host keys are important because host key means that it will be able to decrypt the secret. I'll get to that, why that matters. So I define a secret. I've just finally defined a brand new secret here. So this is my GCP credentials service account. So this would allow anyone to create GCP compute access. Obviously, I don't want to leak that information. And over here is the secret, but it's been encrypted using Age or Agenix. Agenix is a wrapper for Nix over Age. This is Age I'm showing you. And how this works is if I head over into my machine and check out over here, in my machine configuration, I define the secrets. And what happens is when this configuration gets activated, so when I run, say, deploy NixOS, now this might work or it might blow up because I haven't actually tested this one. I'm running on a dirty tree. Nope, it's all good. That's really cool. Check out this line right here. This is the secret I just built. So what happens is the secret is encrypted, and when this operating system activates or boots or what else have you, so right now I've activated a new version of the operating system, At runtime, it will use the host key to try and decrypt the secret, and if it succeeds, it will deploy it over into this beautiful directory. So if I head over to run/agenix, and obviously I'm not going to cat by the contents of these files, but these are secrets, fully decrypted on my host. And each time I rotate my secrets, the secrets are automatically managed. So I'm essentially doing GitOps with Git secrets, and all encrypted with SSH keys. Works really well. Like, it's so simple. It's better than environment variables. I can source these, use bash hooks to like evaluate the contents to bring them into environment variables. But working on bare files is a great way to do it. So yeah, I use Agenix, and this is my brand new secret that I just added just then. So that's really cool. So let's have a look here. Let's look at my diff. So I've added my my secret definition for the machine, and that's what activates it. I have my new binary file, which is the actual secret that's encrypted. I've defined which machines or users. In this case, it's an alias to a list that gets concatenated. I concatenate my users, myself and my management user, and all my hosts together, and that's prod default. And that's it. That's how I do a new secret. Like, they're not a pain. If you do the right infrastructure patterns, secrets are not a pain. There's other sides of secrets where you've got talks of rotation of secrets, etc. But you can, like, if a service is running and you rotate the secret underneath it, how do you ripple up the service rotation? But it's really simple by configuring systemd watches, or some sort of watcher that sees when the file changes, just to restart the systemd service, or virt or cube namespace, not namespace, the pod. Really simple. Feat ghuntley dev add GCP Starlink. Still can't believe this is going by Starlink right now. I'm parked in the middle of nowhere. I've got a large 50-inch television in front of me, and that's everything. Laptop, and this is all going by space. Technology is amazing. See you, Mitch. Thanks for dropping in.